a problem from section 3.3 on freefall motion. This will be problem number 76 on page 84. We have a beanbag that's thrown into the air. So let's see, we have someone standing here, and they have in their hand a beanbag. They throw it up into the air, it hits some high point, and then it comes back down and lands back into their hand. It takes 2.2 seconds after it's thrown to return to the hand of you who threw it upwards. So it is caught 2.2 seconds after it is thrown. We have two questions. The first question is, how high did it go? And we're going to address that question first. The second will be, what was its initial velocity? I encourage you, before watching me solve this problem, attempt to solve the problem on your own. To determine how high it went, first we need to draw our picture, which we've done. We've drawn our picture here. I'm going to make our picture a little bit bigger so we can get a sense of the motion that's going on here. So we have a beanbag that's going up to some high point and then coming back down. It goes up and then it comes back down. At this peak, we know it has a final velocity of 0 meters per second. While it's thrown upwards, it has some positive velocity, and if we like, we could call this our initial velocity vector, right, thrown up. And then once it gets to the top, that initial velocity, that's some positive number, because it's in the positive direction, must at some point hit 0, which it would at its peak, so that it can now become a negative velocity as it heads back towards the negative, right? Its movement is towards the negative, so its velocity would become negative. We know we can split this into two stages of motion. We have the first stage on the left and the second stage on the right. We know as well that these two stages mirror each other, that the time it takes to go up is equal to the time it takes to go down. We also know that the velocity at its peak is 0 meters per second. We also know that our average acceleration for both of these stages the entire time is negative 9.80 meters per second squared. That's our free fall acceleration due to the force of gravity on our object. To determine how high our object went, we need to look at what do we know about the object, besides these things here. Well, if we want to analyze stage 1, we'll say, which is our left side, so the time or the motion of our object as it goes from thrown from the hand, the beanbag from the hand, thrown upwards and reaching its peak. What do we know about it? Well, we know about its average acceleration, negative 9.80 meters per second squared. We also know its final velocity for this stage of motion. In other words, once it reaches its peak, that's the end of stage 1 of its motion, is 0 meters per second, as was stated up here. We also know, because time up is equal to time down, that we can just take that 2.2 seconds and divide it by 2 to get us a time up of 1.1 seconds. What we're asked to find is how high it went. The question of how high our object went is a question of displacement. In other words, it started at some bottom, some 0, and ended up at some non-zero, right? It displaced from an initial position to a final position. So we're asked to find that displacement. That displacement is equivalent to the height that it reached. This is our unknown quantity. So we need a kinematics equation that can relate acceleration, final velocity, time, and height. One does not immediately come to mind. Instead, what we might need to do is find another kinematics quantity and then use that other quantity to find what we need to find. It might just be that we need to find initial velocity first. That's the other thing we don't know about our object. During stage 1, we don't know its initial velocity, how fast it was thrown upwards. This is something else we don't know. But we can pretty easily find that. So let's look at an equation that relates initial velocity, time, final velocity, and acceleration. We have one that would be our first kinematics equation. The final velocity equals the initial velocity, plus the average acceleration times the change in time that acceleration occurred. We apply that to our case. We have a final velocity of 0 meters per second. We have an initial velocity of unknown. We know our average acceleration was negative 9.80 meters per second squared. And we also know the time it underwent that negative acceleration in order to reach a velocity of 0 at its peak, and that was 1.1 seconds. I'm going to leave this initial velocity on its own to the right and move this guy right here, this 9.80 meters per second squared times 1.1. I'll multiply that out real quickly. And I get minus 10.78 meters per second. The seconds cancel here with the meters per second squared times seconds, so I just end up with meters per second, still equaling 0 meters per second on the left. Move this over to the other side and I get positive 10.78 meters per second is my initial velocity. Finally, I'll move it to the appropriate significant figures of just 2 and have it stated as 11 meters per second. Alright, so I know my initial velocity. That was the velocity at which I threw the beanbag, or you threw the beanbag, into the air. Now we know initial velocity. Let's see if we can use that to find the height. Now that we have initial velocity, we have time, we have final velocity, acceleration, right? So I can write this out as positive 11 meters per second. Okay. Now we can relate any of these 4 quantities to this fifth. The easiest might be, or the simplest, might be, we could use 2 equations here because we have so much information. The equation I'm going to use now is v of f squared equals v of I squared plus 2 times the average acceleration times the change in position. Solving this equation for what we need to find, which is the displacement, or the height physically in our case, I find that the final velocity squared minus the initial velocity squared divided by 2 times my acceleration gives me my displacement. So all I did was solve this equation, our third kinematics equation. I solved it for displacement. Putting these values in that I know, the kinematics quantities I know, we have v of f squared is 0, so we have 0 squared, which is just 0, minus initial velocity squared, positive 11 meters per second squared, over 2 times our negative 9.80 meters per second. My numerator is going to end up being negative 121. And my denominator will be 19.6, negative 19.6. Altogether, that gives me a height of 6.17 meters. I'm a little crammed right here. I have 6.17 meters. Again, rounding to appropriate significant figures, just 2. then I end up with 6.2 meters as my height. In other words, when our beanbag was thrown, it was thrown with an initial velocity of 11 meters per second. It reached a height of 6.2 meters. At that point in time, it was traveling with a velocity of 0 meters per second. Then the beanbag started heading back down towards my hand, towards your hand, landing back in your hand 1.1 seconds later. And now its velocity at this moment, right before it hits your hand, is 11 meters per second in the negative direction now. All right, thank you.